Hello, my name is Ye-Chun Kim. In this presentation, I will walk you through Lab 9, which focuses on class inheritance and multi-class implementation using the Kausei project. We will explore how to extend a single utility using object-oriented programming principles. This presentation is divided into 7 main parts. I will begin with a general overview of the lab and its purpose. Then we will look into the class structure I design, followed by detailed discussion of the Dragon and Ice Dragon class implementations. After that, I will walk you through the changes made to the main Kausei program file. And finally, I will talk about a problem I faced during the lab and how I resolved it, and then wrap up with a few key takeaways. The main objective of Lab 9 was to reinforce our understanding of class inheritance in Python by modifying and extending an existing program. We worked with Kausei Utility, a text-based program that prints message alongside ASCII art cows. The task was to create two new types of cows, a dragon and a specialized version of the ice dragon. By doing this, we practice polymorphism constructor chaining with super and method overriding. Here's a visual representation of the class hierarchy used in the lab. Cow is the base class with common attributes such as a name and an image. A dragon extends cow and introduces additional behavior such as fire breathing. Ice dragon in turn extends dragon but overrides that behavior to reflect its ice-based nature. This type of hierarchical class structure is common in object-oriented design when different subclasses share base functionalities, but also require their own specific behavior. Let's take a look at the dragon class. It inherits from cow and uses the super function to call the constructor of the base class. After that, we assign the image property specific to dragons. One of the most important methods here is canBreathFire, which returns true. This method distinguishes dragons from regular cows and will be used later in the main program to determine behavior. This is a great example of how we can add functionality in a subclass. Now we have the ice class. This inherits from dragon, which means it also indirectly inherits from cow. We reuse the constructor using super again, passing both the name and an, an, an image. However, we override the canBreathFire method to return false, which is what makes an ice dragon unique in our program. Overriding is a powerful feature in OOP, allowing us to tailor inherited behavior without changing the parent's class. Uh, the main fire Kausei Python script needed to be updated to incorporate the new behavior of dragons. Uh, we use the isInstance function to determine whether the current cow is dragon or one of its subclasses. If it is, we call the canBreathFire method to check whether it can breath fire. Then, based on that, we print the corresponding message. This demonstrates the use of polymorphism where different classes provide different implementations of the same method. During the implementation, I ran into a design issue. I mistakenly had the Ice Dragon class inherit directly from cow instead of dragon. As a result, the dragon specific logic such as the image handling and the fire breathing check was skipped. Once I noticed the bug, I fixed the inheritance to Ice Dragon of Dragon and Everything worked as expected. This experience reminded me how important it is to carefully follow inheritance chains and respect the intended design hierarchy. To conclude, this lab helped solidify my understanding of inheritance and object-oriented programming. I got hands-on experience with constructor reuse, method of writing, and applying these concepts to a real project. It was a fun and practical way to explore the polymorphism and design patterns in Python. Thank you for watching, and I hope you find this explanation helpful. Yeah, this is all. Bye bye.